Welcome to the final part of this video series. In this video, we will go beyond a single cloud platform, talk briefly about other potential deployment options. In many cases, it is important to provide different deployment options to meet different needs, to deploy apps to on-premises, another cloud platform, or multiple cloud platforms. It's a huge topic. In this short video, we will touch just the surface and explore the possibility. We look into the system diagram. For the front end, there are many options for static website hosting. For example, the front end can be deployed to static website available on nearly all of the major public cloud platforms. For the database, as we walked through in earlier videos, we have the flexibility to connect to the database of your choice by implementing a different persistence service. The only uncertain part from my point of view is the backend. The good news is that it's very straightforward to make the backend function portable. The approach is to containerize it into a Docker container with all its runtime packages and dependencies. Then we can run the container in the serverless container instance or Kubernetes cluster in the cloud, or anywhere as you run Docker container on premises, on edge, or in the cloud. Let's see it in action. Go into the function backend project folder. By the way, I already have Docker for Windows Desktop Community Edition installed on my local machine. We will use it shortly. First, I'm going to use azure-functions core tools, which we used in earlier videos to generate supporting files for Docker. We see two new files, Dockerfile and Docker-ignore, have been added. Let's view them in VS Code. Dockerfile is used to create our own custom Docker image. There are two stages. The first one is from the .NET Core SDK base image. It copies our project to the container, publishes it and its dependencies to an output folder for deployment. The second stage is from azure-functions base image. It contains Azure Function runtime for .NET Core, which is about 30% smaller than the SDK base image. It sets up environment variables needed for the runtime and, very important, copies the output from the first stage to the script root folder. All looks good except one thing. Our function project is using .NET Core SDK 3.1. Good news is that there is SDK 3.1 base image available. So let's change the SDK from 3.0 to 3.1. Save the change. Next, we go to Docker-ignore. It defines all files and folders ignored during Docker image build process to minimize the image size. Let me ignore. Save the change. Now we are going to build the Docker image. Switch back to the command line shell. Call Docker build. Tag or name as function backend. Build from the current folder. The build is successful. List the image with a name. We see the image we just built. Because we didn't specify a tag, so the tag is set as latest by default. There are some environment variables needed in runtime. We can provide them in the command, or let's define them in an env file in advance. Switch back to VS Code and add a new file. Give it a name. First, functions require a storage account to store its state. However, we don't have one available yet, so we set it as use development storage. In a production environment, we should set up a storage here properly. Also, I'm adding some settings needed to connect to the database. Save the change. Go to the command line shell, run the Docker image in the background. Bind host port 7072 to container port 80. Provide the env file we just defined. Give a container name, then image name. The container is up and running. List the running container. We see the container ID, image name, and other properties. For the ports, host port 7072 is bound to container port 80. Call Docker logs to view logs inside of the container. 981 are the first 3 characters of the container ID. In the log, the 5 functions we built are found. Also, the HTTP routes of functions are initialized, and the process is listening on port 80 of the container. Now let's do a quick test. Open another command line shell, side by side, clear URL, localhost, port number is 7072, which is bound to container port 80. Root is VicPlans, which associates with function getVicPlans. Send the request. On the left side, the function getVicPlans is triggered and executed. On the right side, the response contains JSON data from the function which retrieved data from the database. We could carry on to test other functions like add, update, and delete, but let's move on. Once we have finished the test, let's tidy up. Terminate the Docker logs process, kill and remove the running container. We run and tested this Docker image locally. Next, we could push it to a Docker image registry, then deploy it to serverless container instance or Kubernetes cluster in the cloud, or anywhere you run Docker container on premises, on edge, or in the cloud. We come to the end of this video series. The source code is available on GitHub. A complete guide can be found on medium.com if you search Build a full-stack serverless app on Azure. Thank you very much for watching. Hope to see you again.